Strategic choices are decisions made by individuals or organizations that are influenced by the actions of others. In game theory, strategic choices are analyzed by examining the ways in which players interact and compete with each other. The goal of the game theory is to identify the optimal strategies that players can use to maximize their outcomes in different scenarios. One key concept in game theory is the Nash Equilibrium, which is a state that a player's strategy is optimal given the strategies of the other player. In Nash Equilibrium, each player is incentivized to choose the best response to what they expect the other player choose. Meanwhile, we would also expect the other player's decision to be correct. When we make decisions, we often choose the most beneficial outcomes for ourselves rather than most beneficial for all. That means we can often reach a Nash equilibrium in a prisoner's dilemma, which is a failure to cooperate and resulting in a worse outcome. The way to examine a Nash equilibrium is through building a payoff table, where we would first list out all the possible outcomes and then think in terms of what-ifs and make the most beneficial decisions based on the other's move. An example of Nash equilibrium is the prisoner's dilemma. In the game of prisoner's dilemma, two suspects are arrested for a crime and being held in two separate rooms. The prosecutors offers each of them a deal. If one confesses and implicate the other, they will receive a lighter sentence, while the other will receive a harsher one. If both confesses, they will both receive a moderately harsh sentence. If neither confesses, they will both receive a light sentence. In this game, there are two possible strategies for each player: confess or remain silent. If one player confesses, the other player's best response is also confess. If both players confesses, they both receive a moderately harsh sentence, which is worse than if they had both remained silent. If one player remains silent and the other player's best response is to confess, as they will receive a lighter sentence while the other player receive a harsh one. This would lead to two Nash equilibria, which is called multiple equilibria. However, multiple equilibria can lead to scenarios in which both good outcomes and bad outcomes are in equilibrium, and it is hard to prevent the bad equilibrium from happening. In the prisoner's dilemma situation, the best outcome is to both remain quiet. But will one betray the other for the goods? If both players are doubting each other, they would try to confess and push all the harsh punishment on the other, which will lead to the worst outcome. Some real-life examples could be in the case of performance-enhancing drugs. It is the social optimum for athletes to not do drugs, since they're risking themselves to get caught and get banned from attendance. However, since every athlete wants to win championship and get a high score, they will risk getting caught in order to potentially obtain this higher payoff, rather than not doing drugs. Another example could be in the case of carbon dioxide emissions. It is the optimal to lower emissions for the greater goods of the planet. However, many companies choose not to do it in order to maximize their production and profits for their firm.